Hello, my name is Dan Trong. I'm the current mechanical team lead for RoboSub.
Hi, my name is Jack Griffin. I'm a third-year mechanical engineering student, and I am next year's mechanical lead for RoboSub.
Right, so in this part, we'll be doing an overview of the hardware, which involves the frame and mount designs, as well as our manufacturing process. Due to COVID-19, we had limited ability to work in person and limited access to manufacturing tools. This definitely impacted the mechanical team's ability to design, test, and manufacture the AUV. But through online tools, we were able to overcome these limitations and use Zoom and programs such as Fusion 360 to collaborate and work together. And then we also recruited a small fabrication team for manufacturing work, who we were able to give manufacturing access to. The extra time also allowed us to further refine our mount and frame design to ensure that all components followed system requirements and that the overall design was as hydrodynamically efficient as possible.
So, as a system overview, with our new AOV design that you can see here, our goal was to reduce drag, improve maneuverability in the water, and create a custom frame for our new sensors and thrusters. But, of course, due to the limitations that the pandemic created, we also made sure to design the parts to require minimal to no complex machining to make things a little easier for us, while prioritizing the use of machines we had access to, which included bandsaw, drill press, a CNC router, and a 3D printer.
Yeah, so the components we currently have are 8 T200 thrusters, a Teledyne spoil DVL, which is not shown right now, Box Ping 360 sonar system. Right now we have Ping altimeter installed, but this will be replaced soon with the Ping 360. 4 hydrophones, which are not installed right now, 2 batteries, which will go in these 2 containers right here, and 1 electronics container. The electronics are pending manufacturing.
For our thrusters, we actually placed the 4 horizontal thrusters that you can see here on the corners in a vector formation, and the 4 vertical thrusters near the corners of the AV here, which altogether allows for 6 degrees of freedom of motion when moving through the water, which helps us to avoid any component obstruction with how it's placed.
Yeah, so the Doppler velocity log allows us to track movement and therefore location of our AUV. Therefore, it's one of our most important sensors. As such, the sensor needs to have a direct line of sight with the ground, and it must remain still while it's in the mount. Otherwise, any movement can mess with its tracking. Because of these requirements, we designed a mount that's attached to the bottom of the frame, which will go right here, where that gap is between the legs, clear of any other components, and that would prevent any rotation or sliding as the AUV moves through the water.
The Ping 360, which isn't on the current sub right now, but you can actually see in the CAD image below, is used to locate any obstacles around the AUV that the front camera cannot detect and accurately then determine their distance from the sub. This specifically is most helpful when dealing with the competition's torpedo obstacle, with the distance and just overall helps with that. And since it requires not to be obstructed by any components, it was determined that at the top of the sub was the best location for it.
So the hydrophones, which will go in these 4 holes in the corners, they'll allow us to detect specific frequencies of sound underwater. And these sensors are very helpful for us to locate the pingers that are used in the competition. As these sensors need to be clear of any components in order to detect the sound waves, they are mounted at the very edges of the frame. And also, these thrusters and the hydrophones will be set to detect at different frequencies, so the thrusters should not affect the detection of the pingers through the hydrophones.
So we decided to improve based on our previous AOE by allowing for the attachments of 2 batteries to the sub in order to extend the battery life of the system as a whole. You can see we have 2 battery containers in the back. This basically helps us for testing and the competition by allowing for the UAV to perform more trials before the batteries need to be either swapped or recharged. The containers for these batteries were placed close to the electronics container, which in the rear, allowing for easy access and connections between the containers.
Yes, so the electronic container in the front here houses all the boards and 2 cameras that we'll be using. As this component produces the greatest amount of buoyant force, we mount it at the very top to prevent any unintentional rotation of the AUV. And we gave it the front and unobstructed view so that the cameras can identify all of the obstacles. The mounting system allows us to move the front, end cap, right here, the front flange, and the front tube without having to remove the electronics tray, which will be going inside here, which means that we can effectively remove this whole container and have the electronics tray stay here for easy access so the electrical team can easily fix any issues that may arise, any loose wires, or upgrade components without having to fully detach it and undo all of our penetrator cables.
Now, to accommodate all the components, we decided to go for a flat plate frame design. This would basically allow for simple allocation of all the components while also keeping a center of mass and buoyancy in the center of the AOV. The frame was originally designed to be made from aluminum. However, for manufacturing ease during the pandemic, and as a first iteration design, we decided to go for a high-density polyethylene material for this first iteration, which is cost-efficient while also maintaining the required stiffness and strength to hold up all the components while moving.
Mm-hmm. Yeah, so the manufacturing process for the mouse, for these components and the frame was originally planned to be done by the entire team. However, that definitely could not be possible due to COVID-19. So because of lab restrictions, we're only allowed to have 4 people in here at once. So in order to accommodate for this, I decided to recruit 3 individuals who have had previous manufacturing experience. These fabricators, as they are called, are purely focused on manufacturing of the designs which are created by the designers.
For development testing, we began by testing prototypes for a DVL mount that would be attached to the bottom AOV. We also made sure to test our thrusters, and in order to make sure they were functioning properly, that no water flowed through the cables while in use, such things like that. These tests were done using a previous AOV in order to prepare all those components for the new design, which you can see here.
So even though we did not completely finish the grabber and torpedo systems this year, we did get to the point where we were able to test the custom waterproof motors for each system. Each motor was lowered into the pool at a depth of 30 feet and left there for 30 minutes. We performed this test with and without the motors running in both a static and dynamic test, and we found that they passed both tests and functioned at 30 feet for 30 minutes.
In order to test the waterproofing of our containers, we developed a vacuum pump testing system based off of Blue Robotics hand pump. The system we developed uses an electric pump capable of removing about 3 cubic feet of air per minute, which was connected via tubing to a pressure gauge and a connector that could be attached to a container when necessary. These connectors actually can be modified to connect to all 3 containers at the same time, which allows for much easier testing of the containers. This basically allows us to easily test the waterproofing without having to plunge the whole system into a pool, risking the potential damage to the electronics. When testing the containers, basically our requirements were that the pressure inside needed to stay at a stable 15 millimeters mercury for about 10 minutes. And if that stays good, then it's safe to place the sub into the water.
And so that's all for Trying RoboSub 2021. We'll hope to see you next year.